chemical bonding. So we have molecules HCl, H2O, NH3, CH4. These are all molecules. HCl, H2O, NH3 and CH4. In HCl we have hydrogen plus chlorine. That means how many atoms? Two atoms. Two atoms. Here two hydrogen, one oxygen. How many atoms? Three atoms. Okay. In ammonia, NH3. Yes, one. Yes, yes, four atoms. So and so on and so forth. Here it is in five atoms. Okay. So it has a combination of molecules are the combination of atoms. Compounds are also combination of the atoms. What actually is making this hydrogen and chlorine to be together? What is bonding them? What is bonding them? That is what we are going to see in the chemical bonding. How this bonding is happening? Okay, how this bonding is directed? What is the governing force between the molecules, atoms to get and be in the combination, be bonded? Okay, right. Yes, last. Hmm. Yeah. Yes. So bond. What is bond? Bond is force of attraction. Force of attraction. Force of attraction between two atoms. Okay, force of attraction between two or more between two or more atoms. So that is the chemical bond. So what kind of force is here? What is the force? Acting electrostatic force, because those are all electrons only, no? So electrostatic force is developing between them and making them to form a bond. So a definition. What is the definition? Definition: chemical bonding is the attraction, force of attraction between two or more electrons, holding them together in a molecule or a compound. Right? Electrostatic force of attraction between two or more atoms. That force is called as electrostatic force, and it holds two or more atoms together in a molecule or compound, right? So this is about chemical bonding. So what kind of force is between them? Electrostatic force, right? That is governing them. So why these atoms are getting combined? Why they are forming bonds? What's the reason for them to make this kind of bonds? Why bonding? Right? Why actually they are bonding? They are bonding or getting combined because they wanted to become stable. Bonding or getting combined because they wanted to attain a stable position, to get stability. That is the major reason to get stability. How this stability can be attained? Through electronic configuration, right? Electronic configuration, right? It largely depend upon outer shell. Okay, the electrons in the outer shell. Okay, so that is what how they will attain, how how they will attain the stability. They will attain the stability either losing or gaining or sharing. Okay, either they will lose, gain or share. So if, for example, if you are having, okay, we have seen. So if a if it has a two shells, okay, two and one, okay, okay, outer shell it is having only one electron. So what it tend to do, it wanted to donate it one electron, and it wanted to attain the two stable configuration. Okay, for example, in one a particular atom, it has 7 in the outer shell. What it will try to do, if it get 1, it will become 8. It will try to become stable. Okay, so it will receive one electron. So it will attract one electron, it will donate the another electron. In some cases, what happens? It will share the bond. Okay, right? Sharing of the bond, sharing of the electron, right? So this is why it is attaining the bonding. Next, next, how do they bond? How do they bond? Next is how. How? How do they bond? How do they bond? First thing is transfer of electrons, right? Transfer of electrons. We have seen already transfer of electrons. Transfer of electrons means either losing or gaining. Transfer of electrons, right? Another way, sharing of electrons, right? This sharing of electrons. In sharing of electrons, what it will do? Share a, they will share the electrons. Okay, right? So in these two ways we can make the bond. Okay, right. So in transfer of electrons, what they will have, what will transfer? Metals will transfer. Metals always transfer their electrons. Okay, metals always transfer electrons. Metals to non-metals, right? Metals to non-metals, right? Metals to non-metals. Okay, fine. Metals to non-metals. Okay, right. Okay, types of bonds. How many types of bonds we are having? Let us see the types of bonds. Types. Types of bonds. So at our level, these things are important. There are several types of bondings, but the most important types of bondings are electrovalent, electrovalent electrovalent bond, and covalent bond. Covalent bond. What is electrovalent bond? Is nothing but ionic bond. Ionic bond or electrovalent bond, anything you can call it. So in electrovalent bond, what is the major difference between electrovalent bond and covalent bond? Transfer here, transfer of electrons. Simply nothing but ionic bond means transfer of electrons. Here covalent, you see co means what? Sharing. Yeah, okay, sharing. Okay, covalent is sharing of electrons. Okay, mostly it happens in the non-metal to non-metal. No, non-metal to non-metal bonds. Okay, non-metal to non-metal, right? Here transfer of electron will be metal to non-metal, right? See, because always metals are ready to share their electrons, donate their electrons. Okay, so that is the reason we are having uh, metal to non-metal and transfer of electrons, and here co. So with the help of covalent, co in the with this word we can able to understand they are sharing. Okay, so let us move to see some examples. For example, ionic bond. Ionic bond. right? In ionic bond, so let us take right, as we have discussed, metal to non-metal, no, right? We'll take, what is this, sodium, right, and calcium, right, NaCl. See, this is what kind of bond? Ionic bond. How can you say sodium is a metal, chlorine is a non-metal? Okay, easily we can understand. HCl. Are you with me? HCl, right? Here hydrogen, chlorine. Both of them are non-metals. So you can easily say that they are covalent. Okay. So whether you first you need to understand whether it is a metal or non-metal. So it is non-metal, non-metal. Then easily you can say what kind of bond it is forming. Right? Ionic bond. Okay. This is covalent bond. Okay. Right. For example, other examples are the CaO, calcium oxide, NH3, H2O, CH4. These are all what? Covalent bonds. Non-metals. Non-metal to non-metal sharing. Sharing. Sharing only, no. This bond, covalent bond is sharing bond. Okay. Right. Right. Okay. Now we'll check which with each one we'll check. Okay. Right. First of all, CaO. Let us take calcium oxide. Right. CaO. What kind of bond it is forming? Calcium and oxygen. That is ionic bond. Ionic. Yes, metal and non-metal. Okay. Right. Next, NH3. NH3. It is a, yes, non-metal, 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 covalent bond. Okay. You see, right? H2O. We'll daily drink some water, right? So H2O is what? H2O is what? Covalent, non-metal to non-metal, right? So in this manner, we have to check whether it is metal or non-metal. If it is metal, metal to non-metal, you can easily find out that it is a ionic. Yes, yes, we can find it very easily. So next, we'll see one more topic. Levin, 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 Levin electron dot structure. Electron dot structure. They have given a formal structure. Levin electron dot structure. Okay, Levin electron dot structure. It is a representation of electrons, valence electrons. For example, lithium, we have 3. Okay. What is electronic configuration? 2 comma 2 comma 1, since the atomic number is 3. Okay. How many electrons are there in the valency? Valence. Right. So lithium, you can write it as 1. Either you can represent it with the X or you can represent it with the dot. Okay. But you cannot use both in one thing. Okay. Yes. Fine. C, carbon. What is it? Atomic number 6. Yes. 2 comma 4. Right. Now how you'll 4, we have to represent 4 with 4. So you can do it like this, or we can do it like this. Fine. So K19, K19, 2 comma 8 comma 8 comma 1. Right. K, K. You can write like this, or you can write like this. Understood now? So now say it for neon. Ne10, 2 comma 8. So how will you write Ne? So this is the way in which, yes, this is the way in which we will represent in the Levin electron dot structure. You can use this cross symbol or dot symbol, but both symbols cannot be used at a time in the combination. Okay, right. Next we'll see uh, ionic bond. What is how ionic bond is dependent on on what parameters ionic bond is dependent on? Ionic bond depends upon what parameters? Right? Conditions. We can call it as conditions for ionic bond. Conditions. What are the conditions? First one, ionization potential. It depends upon ionization potential. Secondly, electron affinity. Electron affinity. Third one, electronegativity. Electronegativity. So these are the condition in which it will on which ionic bonds will depend. Okay. So for metals, for a bond, ionic bond to be formed, okay, ionic bonds are what? Metal to non-metal bonds, right? So in metal, it has to transfer its electron. No, metal has to transfer its electron, right? So then ionization potential should be high or low. It should be high or low in order to lose an electron. Low, low. Yeah, if you want to lose an electron, your potential should be low. If you are weak only, then only you can able to give your you can able to lose your electron. Okay, so ionization potential should be lowest in the metal. Okay, IP metal ionization potential will be lowest so that it can donate its own electrons to others. Okay, right. So electron affinity. Yes, electron affinity is what? The capacity to receive, how quickly it can receive. Okay, so now metal, this is happening simultaneously. Okay, metal size will be more because then only it can lose. No, this atomic size is more, it is away from the nucleus. This is atom and this is nucleus. This is the outer cell electron. This is atomic size. Okay, right, then only it can able to lose its electron because the distance between this and this is far, so electrostatic force will be less, so it can lose its own electron. Okay, this is what lowest ip. Okay, who is receiving it? Non-metal is receiving it. Non-metal will be comparatively small in size. Okay, atom size. Okay, therefore electron affinity is more. Electron affinity is for more this one. Okay, electron affinity is more for receiving member. Okay, more for non-metal. Understand? Understand? Okay, right. So electron ionization in order to form the ionization bond, what it should be what it should have, what is the condition? Ionization potential should be low. Yes, this will be low, this will be high. Now electronegativity will be no, large. Electronegativity should be large, then only it can able to give. Okay, so that is all, that's all for today. Fine. Let us close this here. Right.